everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to f of y plus ax plus x into g of y plus ax by eliminating the arbitrary functions f and g. We are given a relation and we are asked to form a partial differential equation by eliminating this f and g. So let's see. Given z equal to f of y plus ax plus x into g of y plus ax, right? Consider as equation number 1. Now let's partially differentiate it with respect to x. Now we are going to find the equations involving p, q, r, s and t. Okay. First we will find equations involving p, q, r, t, and finally if necessary we will go for s. Okay. Let's see. Now we'll partially differentiate 1 with respect to x. Just apply dou by dou x on both sides of the equation. You can just do directly, but it is good to apply both sides. I mean, just if you take dou by dou x on both sides of the equation, you can avoid making mistakes. Okay, simply you can avoid mistakes. Now we are partially differentiating with respect to x, so we'll treat y as constant. This gives us dou z by dou x equal to partial derivative of f of y plus ax with respect to x is f dash of y plus ax into inner derivative dou by dou x of y plus ax plus, here we have x and g of y plus ax, right? We are going to apply u v whole dash formula, that is u dash v plus v dash u. So first we'll find partial derivative for x into g of y plus ax plus x into dou by dou x of g of y plus x. Okay, since we have a notation dou z by dou x is p, just replace it by p. You'll get p equal to f dash of y plus ax into partial derivative of y with respect to x is 0 plus a constant into partial derivative of x with respect to x is 1 plus partial derivative of x with respect to x is 1 into g of y plus ax plus x into partial derivative of g of y plus ax is g dash of y plus ax into inner derivative dou by dou x of y plus ax. Okay, this gives us p equal to a into 1a plus 0a. A into f dash is a f dash, that is a into f dash of y plus ax plus 1 into g of y plus ax is g of y plus ax, it's g. Okay, plus x times g dash of y plus ax into partial derivative of y with respect to x is 0 plus a into partial derivative of x with respect to x is 1. Right? This gives us p equal to a into f dash of y plus ax plus g of y plus ax plus a into 1a, a plus 0a, a into x, ax into g dash. G dash is nothing but g dash of y plus ax. Now consider as equation number p. See, we got the equation involving p. Now we will find equation involving q. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y, just apply dou by dou y on both sides of 1, or you can skip it and do directly if you are really good at partial differentiation. So in order to avoid mistakes, I'm giving every step, okay? Fine. Now partial derivative, this gives us dou z by dou y. Here we are partially differentiating with respect to y, so we'll treat x as constant, and this is y. Partial derivative of f of y plus ax is f dash of y plus ax into inner derivative dou by dou y of y plus ax plus, here you're having x which is constant, right? Write x into partial derivative of g of y plus ax is g dash of y plus ax into inner derivative dou by dou y of y plus ax. Since we have a notation dou z by dou y equal to q, let's replace it by q equal to f dash into partial derivative of y with respect to y is 0 plus partial derivative of a constant with respect to y is, partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0 plus x into g dash of y plus ax into partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0, right? Here a is treated as constant, okay? Fine. Now we'll get q equal to 1 plus 0, 1. 1 into f dash is f dash, that is f dash of y plus ax plus 1 plus 0 is 1. 1 into x, x into g dash is x g dash, x into g dash of y plus ax. Consider as equation number, say, 3. Now we got equation involving q, right? Q equal to f dash of y plus ax plus x into g dash of y plus ax. Now we'll find equation involving r and equation involving t, and if necessary we'll go for s also. Here r is nothing but dou square z by dou x square, right? We can write this as dou by dou x of dou z by dou x, and also we know that dou z by dou x can be replaced by the notation p, so we'll get, right, or dou p by dou x gives r, or dou by dou x of dou z by dou x gives r, or dou square z by dou x square gives r, okay? All these terms represents r simply. So in order to find equation involving r, what we'll do is, here p, we have equation involving p. P is nothing but dou z by dou x, right? So by partially differentiating equation 2 with respect to x, we'll get the equation involving r. Let's see. Partially differentiating equation 2 with respect to x. Just apply dou by dou x on both sides of 2. Right? Here we are partially differentiating with respect to x, so we'll treat y as constant, and this gives us dou by dou x of, here you can just write r, okay, since partial derivative of p with respect to x gives r, but what I'm going to do is, I'll write it later, okay? I'm having too many steps to write, so I'll write this p as dou z by dou x, since p is nothing but dou z by dou x, right, equal to constant a into partial derivative of f dash of y plus ax with respect to x is f double dash of y plus ax into inner derivative dou by dou x of y plus ax plus partial derivative of g of y plus ax with respect to x is g dash of y plus ax plus inner derivative, into inner derivative dou by dou x of y plus ax plus a into, here we are having x and g dash of y plus ax, right? Here we have x and here also we have x. So we'll treat x as u and g dash of y plus ax as v, and we'll apply uv whole dash formula. Okay, a times dou by dou x of x into g dash of y plus ax plus dou by dou x of g dash of y plus ax into this x. Clear? Fine. This gives us dou square z by dou x square equal to a into f double dash of y plus ax into partial derivative of x with partial derivative of y with respect to x is 0 plus a into partial derivative of x with respect to x is 1 plus g dash of y plus ax into partial derivative of y with respect to x is 0 plus a into partial derivative of x with respect to x is 1 plus a into partial derivative of x with respect to x is 1 into g dash plus x into partial derivative of g dash of y plus ax is g double dash of y plus ax into inner derivative dou by dou x of y plus ax. Okay, this gives us, since we have a notation dou square z by dou x square equal to r, we'll replace it by r, since dou square z by dou x square can be replaced by the notation r. Okay, we'll get r equal to a into 1a plus 0 a into a square f double dash of y plus x plus a into 1a into, okay, a plus 0 a into g dash is a g dash. Okay, plus 1 into g dash is g dash, g dash into a is a g dash, right, plus a into x ax g double dash, and here we need to find inner derivative, right, into partial derivative of y with respect to x is 0 plus a into partial derivative of x with respect to x is 1, right? Fine. This gives us r equal to a square f double dash of y plus ax plus a g dash plus a g dash is 2a g dash, right? Plus a into 1a plus 0 a into a square x g double dash. Consider as equation number 4. We got equation involving r, right? R equal to a square f double dash of y plus x plus 2a g dash of y plus x plus a square x g double dash of y plus x, which is equation number 4. Now we have to find equation involving t. T is nothing but dou square z by dou y square, right? Or we can write this as dou by dou y of dou z by dou y. Since we know that dou z by dou y is q, we can write this as dou by dou y of q or dou q by dou y. So by partially differentiating the equation involving q with respect to y gives t. Here is the equation involving q. So we'll partially differentiate it with respect to y to find the equation involving t. Okay, let's see. Now let's partially differentiate equation 3 with respect to y. Just apply dou by dou y on both sides of 3. It is not necessary to write dou by dou y on both sides of the equation. Just to avoid mistakes, we are taking dou by dou y on both sides of equation 3. You can do directly. Okay. Fine. Now, here itself you can write dou q by dou y as t, but I'll write this. I'll just replace q by dou z by dou y equal to partial derivative. Here we are partially differentiating with respect to y, so we'll treat x as constant. And partial derivative of f dash is f double dash of y plus ax into inner derivative dou by dou y of y plus ax plus x constant into partial derivative of g dash is g double dash of y plus ax into inner derivative dou by dou y of y plus ax. This gives us dou square z by dou y square equal to f double dash of y plus ax into partial derivative of y with respect to y is 1 plus partial derivative of a constant with respect to y is 0 plus x into g double dash of y plus ax into partial derivative of y with respect to y is 1 plus partial derivative of ax with respect to y is 0. Since we have a notation dou square z by dou y square equal to t, we'll just replace it by t. We'll get t equal to 1 plus 0, 1. 1 into f double dash is f double dash. Plus 1 plus 0 is 1. 1 into x is x. X into g double dash is x, g double dash. Which is equation number 5. So we got an equation involving t here. That is t equal to f double dash of y plus ax plus x into g double dash of y plus ax is considered as equation number 5. Now observe all the 5 equations. Here we have f plus x g, and here we have af dash plus g plus ax g dash. Here we have f dash plus x g dash, a square f double dash, 2a g dash, a square x g double dash, f double dash plus x g double dash. So if you observe, we can say that it's not enough to find the partial differential equation. So now what we are going to do is we'll find s also. S is nothing but dou square z by dou x dou y, right? Let's see. S is nothing but dou square z by dou x dou y. We can write this as dou by dou x of dou z by dou y, or dou by dou y of dou z by dou x. Okay, this gives us dou by dou x of dou z by dou y is nothing but q, and this gives us dou by dou y of dou z by dou y, sorry, dou z by dou x is nothing but p. So by partially differentiating equation involving q with respect to x gives s, or by partially differentiating equation involving p with respect to y gives s. We have both the equations p and q. You can pick any of these two. If you want to pick p, you have to partially differentiate it with respect to y. If you want to pick q, you have to partially differentiate it with respect to x. Okay, so let's go for q. This is a smaller one, I guess, right? Right. Now I'll choose this one. Partially differentiating equation 3 with respect to x. I'll just apply dou by dou x on both sides of 3. See, here we are having 3 terms, but in q we have 2 terms, so I'm going to try it for 3. You can take any of these two. This gives us dou by dou x of q is nothing but dou z by dou y. Here itself you can write as, okay. Partial derivative of f dash with respect to x is f double dash of y plus ax into inner derivative dou by dou x of y plus ax plus here you're having x and here also you're having x. Consider x as u, this term as u and this term as v, and apply uv whole dash formula. Okay, you'll get dou by dou x of x into g dash plus x into partial derivative of g dash of, that is dou by dou x of g dash of y plus ax. Okay, this gives us dou square z by dou x dou y equal to f double dash of y plus ax into partial derivative of y with respect to x is 0 plus a into partial derivative of x with respect to x is 1 plus partial derivative of x with respect to x is 1 into g dash of y plus ax plus x into partial derivative of g dash with respect to x is g double dash of y plus ax into inner derivative, that is dou by dou x of y plus ax, right? Since we have a notation dou square z by dou x square equal to s, just replace it by the notation s, you'll get s equal to a plus 1, sorry, a into 1 a plus 0 is a into f double dash is a f double dash plus 1 into g dash is g dash plus x into g double dash of y plus ax into dou by partial derivative of y with respect to x is 0 plus a into partial derivative of x with respect to x is 1. Okay, this gives us s equal to a into f double dash plus g dash plus a into 1 a plus 0 a into x ax into g double dash. Consider as equation number 6. Okay, fine. We got equation involving s equal to a f double dash of y plus ax plus g dash of y plus ax plus ax g double dash of y plus ax. Fine, now observe all the 6 equations that we have. So we have RTS, which involves f double dash and g double dash, right? So observe these 3. In T we have f double dash plus xg double dash, right? In S we have a f double dash plus ax g double dash, right? If you take a common from these two terms, we'll get a times f double dash plus x into g double dash, which can be replaced by t, right? Likewise here also we have a square f double dash plus a square x g double dash. Okay, and by taking a square common from these two terms, we'll get a square times f double dash plus x g double dash, which can be replaced by t. Okay, so now we'll start with t. Okay, we'll start with t and let's see what happens then. We have 5, that is f double dash into y plus ax plus x times g double dash of y plus ax equal to t. Okay, fine. Now consider 6. From 6 we'll have a into f double dash of y plus ax plus g dash of y plus ax plus ax into g double dash of y plus ax equal to s. Now what I'll do is, I'll just take a common from these two terms, so that I'll get a times f double dash of y plus ax plus x into g double dash of y plus ax plus this g dash, the remaining term, okay, equal to s. Since we have f double dash plus x into g double dash t, so just replace it by t, we'll get a into t plus g dash of y plus ax equal to s, right? From this you'll get g dash of y plus ax equal to s. Just take this term to RHS, you'll get s minus at. So we'll use this and this for the, consider as 7 and this as 8 if necessary. Now coming to r, we have r, equation number 4, right? That is r equal to a square f double dash plus 2a g dash plus a square x g double dash. Right, now just take a square common from these two terms, you'll get a square times f double dash plus x g double dash plus 2a g dash, the remaining term 2a g dash, right? By 8 we have g dash of y plus ax is s minus at, so replace it by s minus at, and by 7 you have f double dash plus x g double dash equal to t, replace it by t, you'll get r equal to a square into t plus 2a into s minus at. We just use these two. Okay, fine. See, we have eliminated f double dash and g double dash and g dash. So you don't have any f or g's. Okay, you don't have any f's or g's, right? Now we have to simplify it. Right, this gives us r equal to a square t plus 2as minus 2a into at, 2a square t, right? R equal to a square t minus 2a square t gives minus a square t, right? So let's write the term involving positive sign first. You'll get 2as, okay, minus 2a square t plus a square t gives minus a square t, right? Now we can take these two terms to LHS, you'll get r minus 2as plus a square t equal to 0, which is the required partial differential equation. Okay, easy. Therefore, r minus 2s plus a square t equal to 0 is the required partial differential equation. This completes the problem, right? Fine. And I showed you s by partially differentiating q with respect to x. You can also try using dou p by dou y. Okay, I'll just solve and I'll show you. So this is your s, that is equation involving s. So you got the same thing by partially differentiating on both sides of p, that is equation 2. Okay, fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, Bye bye.